Chapter 2, Section 6, Solving Absolute Value Inequalities. Like I said, this is the last section of Chapter 2. So, probably at some point next week, we will be getting a test over Chapter 2. So be ready for that. Do you guys remember solving absolute value equations? If I had the absolute value of x plus 3 equals 5. What were the steps we took to solve this? What was the very first thing I always checked? Make sure the absolute value is completely by itself. Nothing happening outside of those bars. You guys remember that? We want to do the same thing today with our absolute value inequalities. Make sure the absolute value is always completely by itself. What do we do next after we made sure it was by itself? Because this is by itself, correct? What do we do next? Say it again. What did I have to check in order to be able to do that? Yeah, make sure your C value is greater than or equal to 0. If your C value is greater than or equal to 0, you can set up your two equations, right? If it's less than 0, what was my answer? No solution, because my absolute value cannot equal a negative. Okay? The C value part's not going to be exactly the same today, but we will have to deal a little bit with our C value and do stuff with our C value. Okay? So, our C value is greater than or equal to 0, so we set up our two equations. What does the first one look like?
X plus 3 equals 5.
Oops. X plus 3 equals 5, exactly the same without the bars. What was the second one?
X plus 3 equals negative 5.
X plus 3 equals negative 5. With our absolute value inequalities, we'll do something similar, but there will be a little bit difference. Okay? And then we solve these. Subtract 3, we get 2. Subtract 3, we get negative 8. Is everyone okay with that? Today, we will get two inequalities set up, depending on our C value. And it'll create two inequalities for us. What did we talk about yesterday and the day before that? You guys remember? What was 2.5 about? Compound inequalities, which is two inequalities put together with the words and or the word or, correct? So when we create our two inequalities here, we're going to make it a compound inequality by putting the word and or between them to make one compound inequality. So, on your paper, I want you to write the word goal exactly the way that I am writing it. Write goal just like that. If you notice, we've got a greater than symbol in there, and we've got a less than symbol in there. That is going to help us determine if it's going to be and or. And I'll show you how we use that when we get to our examples. Okay? Did everyone get that written down? Everyone somewhat remember absolute value equation. Okay, let's get into absolute value inequalities here. So, to solve the absolute value of ax plus b is less than c, for c is greater than 0, solve the compound inequality. Ax plus b is greater than negative c, and ax plus b is less than c. So, I'm going to go ahead and write goal up here again. If you notice, our inequality symbol here is less than, correct? If your original symbol starts off as less than or equal to, find less than on the word goal. What letter is it next to? A, it's going to be an and compound inequality. Does that make sense? Everyone got that? Okay. Whenever we set up our two inequalities, like we said earlier, we want to make sure the absolute value is completely by itself. And for our inequalities, we want to make sure our C value is always just greater than 0. Okay? Does everyone see that? If our C value is less than 0, we'll get to an example that when C value is less than 0. But when it's greater than 0, we can set up our compound inequality. Okay? Just like with our equations, the first inequality will be the exact same without the bars. Does everyone see that? I don't know why they always put the negative one first, but I like to write this one first because it's exactly the same without the bars. Does everyone see that? Just like with our equations, correct? Our second one, right here, is exactly the same. There's two differences, though. Does anyone see the two differences?
C value is negative, and then it's greater than.
Very good. Our C value is negative, and then we flip that inequality symbol to account for that negative that we threw in there. Okay? So first one's exactly the same without the bars. Second one, exactly the same. Make C negative. Flip your symbol. Okay? So those are the key differences when we're setting up our two inequalities. And then, like I said, starts off as less than. Less than's next to the A on goal, so I know it's an and compound inequality. Okay? From there, I would just solve like we solved the past 2 days. Everyone got that? Okay, similarly, down here, to solve absolute value of ax plus b is greater than c. Once again, for c is greater than 0. Solve the compound inequality. What do we notice about this first one over here that I'm going to have you guys write first whenever we're writing them? How does this compare to the original? Exactly the same without the bars, just like with our equations. Okay? Second one. Exactly the same. Make your C value negative. Flip that inequality symbol. Everyone good with that? My original inequality symbol was greater than. Everyone see that? Find greater than on the word goal. What letter is it next to? O, so it's going to be an or compound inequality. Goal will be really helpful in determining if it's and or. Okay? And then, once again, we just solve those individually. Keep the word or between them. We have our compound inequality as our solution. Okay? In the inequalities above, you can replace less than with less than or equal to. And you can replace greater than with greater than or equal to. The same rules will still apply if those symbols are in play. Okay? Are there any questions before we jump into some examples? I feel like we get more benefit from just doing the examples anyways. We good with that? All right. Solve each inequality, graph each solution if possible. Absolute value of x plus 7 is less than or equal to 2. Absolute value of x plus 7 is less than or equal to 2. Let's go through our steps here. First off, is our absolute value completely by itself on one side of the inequality?
Yes.
No addition, subtraction, multiplication, or division outside the bars. Yeah, it's completely by itself. Check. Is our C value greater than 0? Yes. So that means I can set up my two inequalities and I can decide if it's and or. If I were you guys, I would always write goal at the top of my paper. Even when we get to the test, write goal at the top of your paper. So, I'm setting up my two inequalities. What's the first inequality going to look like here?
X plus 7.
Less than or equal to 2. Exactly the same without the bars, correct? Everyone okay with that? What's my second one going to look like?
X plus 7 greater than or equal to negative.
Very good. Flip that inequality symbol, make that C value negative. So everyone see how we got those two inequalities. It's going to follow that same pattern every time. Okay? My original Inequality symbol is less than or equal to. So is it going to be and or? And. I find the less than symbol on goal. It's next to the A. I know it's going to be an and compound inequality. Not too bad. Now I just got to solve these two inequalities individually. What's my first step on both of them? Subtract 7 from both sides. 2 minus 7. Negative 5. Symbol flip or stay? Stay. Keep the word and between them. Negative 2 minus 7. Negative 9. Symbol flip or stay? Stay. Are both x's now by themselves? Yes. So here is my solution for my absolute value inequality. Any number that is less than or equal to negative 5 and greater than or equal to negative 9 is a solution to this absolute value inequality. We good with how we got that? Now I've got to graph it. This is just like the past 2 days' assignments, right? Just graphing a compound inequality. Open or closed circle on negative 5? Closed. It's got that bar underneath that inequality symbol. Open or closed circle on negative 9? Closed. Once again, it's got that bar under it. It's an and compound inequality. So do I want the intersection or the union of the two graphs? What? Intersection. X is less than or equal to negative 5. Would that be shaded to the left or right of negative 5? Left. X is greater than or equal to negative 9. Would that be to the left or right of negative 9? Right. So if this one's being shaded to the left, this one's being shaded to the right, where would the intersection of the two shaded regions be? The overlap? Where would the two shaded regions be the same? Between your two circles. So here's the graph of your solution. Any questions on example 1A? How do I feel after one example? Very similar to absolute value equations, just a few small differences, but they're not too bad, I don't think. Okay? Can I erase A and move to B? Absolute value of 8x minus 11 is less than 0. Who wants to help me out on this one? Raise your hand if you can help me out. Can anyone help me out? Take a shot at it. Okay, is my absolute value completely by itself? Yes. Is my C value greater than 0? No. It equals 0, right? But it's not greater than 0, is it? So I've got to look at the statement that it's saying here. Absolute value of 8x minus 11 is less than 0. No matter what number I plug in to this absolute value, I'm always going to get what? A positive or 0, right? Will a positive number or 0 ever be less than 0? No. So do I have any number that'll make this work at all? So what's my answer? No solution. So everyone understand that? When your C value is not greater than 0, aka it's equal to 0 or less than 0, I've got to see what that statement is saying. Okay? In our case, it's saying that that the absolute value is going to be less than 0. So it's going to be some negative number. That's never going to be the case with an absolute value. It's always going to spit out a 0 or a positive number. Everyone okay with letter B? That one was easy, wasn't it? Can I move on to some more examples? These are my last 3 examples here. Number 4, absolute value of x plus 3 is greater than 8. I'm always going to have goal at the top of my paper. Number 4, is the absolute value completely by itself?
Yeah.
Yes, it is. Is my C value greater than 0?
Yeah.
Yes, it is. That means I can set up my 2 inequalities to create my 1 compound inequality. What's the first one going to be?
X plus 3 is greater than 8.
Exactly the same without the absolute value bars. Just drop the bars, you got your first inequality. I want to see you write out this first inequality. Some people with our equations got in the habit of just leaving this and then writing the next one next to it and just solving from here. I want to see you write it out. Everyone got that? What's my second inequality going to look like?
X plus 3 is less than negative 8.
Very good. Make the C value negative. Flip that inequality symbol. What's my original inequality symbol?
Greater than.
Greater than. So is this going to be an and or an or compound inequality? Or. I've got the greater than symbol next to the O, so I know it's going to be or. Everyone okay with how we set this one up? What's the first step on each of these? Subtract 3 from both sides. 8 minus 3.
5.
5. Symbol flip or stay? Stay. Bring down the word or. Negative 8 minus 3.
Negative 11.
Negative 11. Symbol flip or stay? Stay. Here's my solution. X is greater than 5 or x is less than negative 11. Open or close circle on 5?
Open.
Open. Open or close circle on negative 11? Open. This is an or compound inequality. Do I want the intersection or the union of the 2 graphs? Union. So I'm just graphing them on the same graph. Okay? So x is greater than 5. Would that be to the left or right of 5?
Right.
Right. So I'm shading to the right of 5. X is less than negative 11. Would that be to the left or right of negative 11? Left. And there's the graph of my solution. Any questions on number 4? How are we feeling? Good? Everyone feeling good, or at least everyone feeling okay? Anyone feeling awful and like this does not make any sense at all? All right. Can I erase 4 and move to 5? On number 5, is my absolute value completely by itself? No. So, I need to use my inverse operations to get the absolute value completely by itself first. What do I need to do to get it by itself? Add 3 to both sides. Over here I get the absolute value of n plus 2. What's negative 6 plus 3? Negative 3. Symbol flip or stay? Stay. When's the only time the symbol flips? Anytime you multiply or divide both sides of the inequality by a negative number, I've got to flip that symbol. Is the absolute value now by itself? Yes, it is. Is my C value greater than 0? No. So I cannot just jump straight to setting up my two inequalities, can I? I need to look at the statement that is being said right now. It says the absolute value is greater than or equal to -3. No matter what number I plug into the absolute value, what am I always going to get? A positive number or 0, correct? Will a positive number or 0 always be greater than or equal to -3? Yeah, right? It will always, always, always be greater than or equal to -3. So what's my answer here? What? All real numbers. So just because you have a negative on that side of the inequality does not automatically mean no solution anymore. In this case, it means all real numbers. No matter what number I pick to plug in, this is always going to give me a true statement. Okay? It'll always produce a true statement. No matter how hard you try to disprove it. Does everyone understand number 5 and why it's all real numbers? We good? Can I erase and move to our last example? Number 6. Is my absolute value completely by itself? No, that's the very, 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 very first thing I need to do. Right? Always get the absolute value by itself first. What would be my first step to get it by itself? Add 7 to both sides. 3 times the absolute value of d plus 1. -1 plus 7 gives me 6. Symbol, flip, or stay? Stay. Is my absolute value now by itself? No. I still have that 3 outside of the absolute value bars. How would I get rid of that 3? Divide. The absolute value is being multiplied by 3. Inverse of multiplication is division. So I get the absolute value of d plus 1. 6 divided by 3 is 2. Symbol, flip, or stay? Stay. We okay with that? I'll slow down a little bit, let you guys catch up. Any questions up to this point? Is the absolute value now completely by itself? Yes, it is. What's my C value now? 2. Is 2 greater than 0? Yes. So that means I can set up my two inequalities. Okay? What's my first inequality going to look like? D plus 1 is greater than or equal to 2. Exactly the same without the bars. Oh, before I forget, on number 5, we did not graph it. How would I have graphed all real numbers? Yeah, you shade the whole graph. So you would need to graph that one. I forgot. I apologize about that. But on number 5, it would need a graph. Does it matter what numbers you put on your number line there? No, it does not matter which numbers. Just make sure you get the shaded region and put arrows on your shaded region. Okay, back to 6. What would my second inequality look like?
D plus 1 is less than or equal to -2.
Very good. Flip that inequality symbol. Make that C value negative. And that gives you your second inequality. Now, we want to look at the inequality symbol from when the absolute value was by itself. So I'm looking at this inequality symbol right here. What is it? Greater than or equal to. So does that mean I'm going to have an or an and compound inequality? Or. This greater than symbol's next to O on goal. I know it's or. Questions how I set this up? What's the one step on both of these to get D by itself? Subtract 1 from both sides. On the left, what's 2 minus 1? 1. Symbol, flip, or stay? Stay. Bring the word or down. You've got to have that word there. Over here, what's negative 2 minus 1? Negative 3, symbol flipper stay. Stay. Both D's are now by themselves. There's my solution. Any questions how we got that? Can I erase my work on the left to make room for me to graph?
Yeah.
Open or closed circle on 1.
Closed.
Closed. It's got that line underneath it. Open or closed circle on negative 3.
Closed.
Closed. Do I want the intersection or the union of the two graphs? Union. It's an or compound inequality. So I'm just graphing the two graphs on the same number line. D is greater than or equal to 1. That'd be to the left or right of 1.
Right.
Right. D is less than or equal to negative 3. Left or right of negative 3? Left. And I'm done with the problem. Are there any questions about solving absolute value inequalities? Very similar to absolute value equations, just a few differences. We good? All right. Here's your assignment. Page 95, 2 through 18 evens. That's 9 problems for you. Make sure you get this written down and get the correct heading on your paper. Name, date, period, assignment in the upper right-hand corner. If you don't finish this in class, this is due Monday, the 9th on Canvas. Are there any questions about the notes before I end the recording?